children, hello, welcome to your home school this year. One more session of your mathematics basics. Mathematics, we deal with the mostly three important branches in mathematics. What are the three branches? Arithmetic, geometry and algebra. In arithmetic, we are going to deal with only numbers. Whereas in our geometry, we deal with the shapes. And in algebra, we are going to deal with the variables, numbers, literals, combination of variables and numbers. Today in this session, we are going to discuss about the basics of algebra. What is algebra? Algebra is the generalized form of arithmetic. In arithmetic, we deal with the numbers such as 5, 15, 20 or 7 by 5, minus 10. Like this, we use with the arithmetic. Algebra, it is a generalized form of arithmetic. Means in this, we use with the variables and also numbers. The letters used in algebra are called variables or literal numbers or literals. Example, let me take the variables x, y, a, b, p, q, so on. There is no end. All the alphabets are considered as a variables. Right? So, these are the variables or a literal symbols or literals. Literal numbers we may call or a literals or variables. Why we call that? Whereas here in arithmetic, the numbers will be having a fixed value. If I say this number 5, does it change? No, it's 5 itself. But whereas in your algebra, suppose if I say you this x value, it's not a fixed value. Whereas this is a fixed value. This value will be changing. So it is not a fixed value. So variables, always the value will be varying. So we call them as a literals. Let's see here. Constant. What is the constant? It is a symbol with a fixed numerical value. In all situations is called a constant. Constant is nothing but a arithmetic you can analyze here. So it is one of the number you may call. Number, what is a number? It is one of the symbol. What we call a numbers, right? Those are all the symbol or a representation of a symbols in mathematics. A symbol with a fixed numerical value in all situations is called as a constant. Whereas the number value won't be changed and its value is fixed. So 2 value is 2 itself. 15, 7 by 4, root 2, root 5, like this. All these are all called as the constant. Constant means the value will be fixed and the value will never change. Coming to your variable, a symbol whose value changes with situation. See, this value is not fixed. It will be changing according to the situation is called as a variable. So, example, x, p, q, a, l, m, n, any alphabetical letter we use as a variable. Okay, understand here carefully. What is algebra? In algebra, some letters we use in algebra are all called as a variables. Algebra deals with the combination of variables and numbers. Okay, and here constant means it is having a fixed value. The symbol or a numbers we use will be fixed. There won't be any change. Coming to your variables, what the letters or a symbols we use will be varying according to the situation. So it does not have a same value always. X, we call it as x, but x value will be changing. X is equal to 5, x is equal to 10. Sometimes x may be negative. This is all we are saying. Means x value is always changing according to the situation. So next, a term. What is a term? A term is a constant or a variable or a product of what? Constant and variable, or a quotient of constants and variables. These are all we come across in this chapter. What is a constant? Fixed number. Variable, the symbol, it is one of the symbol and the value of this variable will be changing always. Term. What is a term? Term, we call it as either it may be a constant or a variable or a product of constant and variable or a quotient of constant and variables. So let's see the examples here. What is 4, children? You say according to this points, you say 4 is a constant number. Okay. It is a term. Though it is a number, I call it as a term. 4 is a term and it is a constant. It is a constant number or it is a constant. See the next example here, x. What is x? It is a symbol or it is a variable and its value will be always changing according to the situation. So this is what? Is this a term? Yes, it is also a term. X is a term and whereas it is a variable. And now see the next one. 4x. When I say 4, it is a constant. When I say x, it is a variable. But combination, product of a constant and variable is a term. 4x is a term. How it is a term? It is a product of constant and variable. This is a product of constant and variable. We call it as a term. Next, 3 by y. What is this 3 by y? Is it a term? Yes, it is a term. 3 by y is also a term. It is a quotient of constant and variables. Constant and variable. It is a quotient of constant and variables. You need to write their statement. Algebra is one of the part of mathematics. Okay, whereas in arithmetic we deal with numbers, algebra deals with the variables. Okay, in this variables is also called as the literals or literal numbers. Now constant means fixed value and it is deals with the number. Variable, and it's represented by a letters, alphabetical letters or alphabets we call, and their value will be always changing according to the situation. They does not have any fixed value and the value will be varying. Coming to term, when we call a term, which one we call it as a term? A term, it might be a constant, it might be a variable or a product of constant and variable or the quotient of constant and variable. All these we call them as a terms. Before seeing like terms and unlike terms, we used to know now 2 points. What are the 2 points here, children? Product or factors and coefficient. What is a product? You know everybody, product means multiplication. Here in this algebra, product. A product is a result of multiplication of 2 or more constants. Constant means numbers. Or literals or of both. Literals, variables or of both. Example, I may say here 2xy. 2xy, how can you write? It is a product of a number and 2 variables or 2 literals, 1 constant. If you multiply one constant with the two variables, we get a product of 2xy. Example, one more example. Let's take one more example here. 5x square. How do you get, children? 5 is a constant. X square. X square. How do you get this answer? If two literals are multiplied to a constant, two same literals, x into x, x square. 5x square is a product of these values. Okay, is a product of these constant and variables. When we multiply these, we get the product, and those are all called as the factors. Okay, if we multiply the factors, we are going to get the product. Coefficient. Any factor or a group of factors of a product is known as a coefficient of the remaining factors. What does the statement indicates? Suppose, let me take one example. 3xyz. Write this, split this into factors, children. 3xyz. Look here. Product I am writing here. Separate 3 into x into y into z, right? Or you may write this 3 dot x dot y dot z also you can write. Now, what I can say here? 3 is a coefficient. 3 is a coefficient of, other than 3, you say here, children, other than 3, what do you have? X, Y, Z. 3 is a coefficient of x, y, z. When I talk about only number, 3 is a constant or it is a numerical coefficient of x, y, z is 3. What does a numerical means? Number. Numerical coefficient of this 3x, y, z is 3. Algebraic coefficient of 3x, y, z means other than number, remaining terms what do you have? X, y, z. We call x, y, z as the coefficient or algebraic coefficient of this product. Okay. So now next one. Only 3 numerical coefficient. If I ask you x, other than x, remaining all same, children, observe here. X is a coefficient of, other than x you say here 3, y, z. Similarly, y. If I ask you only one literal, I am asking here. Y means other than y. Y is a coefficient of 3xz. Other than that letter, you need to say remaining letters. Means these are all the factors. You may say. Suppose if I ask you z. Z is a coefficient of 3xy. Okay. If I ask you 3x. What is the coefficient of 3x? 3x is a coefficient of yz. What is the coefficient of xz? Xz is a coefficient of 3y. Like this, you need to split one product into factors. Every letter or every number, every literal or a constant is a coefficient of other values. So, any factor or group of factors of a product is known as the coefficient of the remaining factors. So, terms means constant, variable, and a product of constant and variable, and a quotient of constant and variable. We call them as terms. So, now terms we can decide either they may be like terms or unlike terms. How can we say? Like terms. The terms having the same literal coefficients. Literal coefficient means algebraic coefficients. Are called like terms. They differ only in their numerical coefficients. Example, 2x, 5x, 50x, 1000x, so on. Look here. What is the literal coefficient here? X is a literal coefficient. Okay, and here literal is same. In all these, X is same, whereas the numbers are different. Numbers means numerical coefficients. What do you have? 2, 5, 50, 1000. So no need of considering numbers here. Check whether variables are same or not. Or the literal coefficients are same, then we call them as a like terms. What are those? Like terms. One more example. 10x square y, only x square y, and 25x square y. So on. Look here. So on means maybe many terms there. Or we can stop your terms here. So look here, what happens? The literal coefficient or the algebraic coefficient, identify here, x square y, x square y, x square y. Observe the numerical coefficient 10, 1, 25. So numerical coefficients may differ, but whereas algebraic coefficient is same. Okay, if they are same, then all these terms we call them as a like terms. Next, unlike terms. The terms that do not have the same literal coefficient are called unlike terms. Example, 3x, 3y, 3p, etc. So look here. Observe the literal coefficient x, y, z. In all these it is differing, means it's not same. Whereas the numerical is same, but we should not consider with the numerical. Always in terms we should say with the literal coefficient. So what is this, children? These terms are called as a unlike terms. One more example, let us see. 2x square y, 3x square, 4x, so on. These are all different. All algebraic coefficients are different and numbers are different. We don't need of bothering about numbers. We see only these literal coefficients. If they are not same, then we can say these terms are unlike terms. If they are same, we call them as a like terms. An algebraic expression. What is an algebraic expression? Algebraic expression is a collection of one or more terms which are separated from each other by plus or a minus sign. So what is this, children? We call as a term, variable, constant, we have said. Then what is algebraic expression here? We get an expression by using two terms or one term or three terms. How many terms you use to frame the expression with a positive or negative sign in between them. Okay, so look here, depending on the terms you are using, we call it with a different names. These every algebraic expression, by using the number of terms, its name will be changed. What is that? Therefore, the types of algebraic expressions. So look here, if an algebraic expression having only one term, what is that algebraic expression we call, children? That is called as a monomial. What is a monomial? An algebraic expression with only one term. Example, 5x, 3yz or 10y square. See, all these having only one term. Look here, you may be confused. 5 is a constant, x is a literal. But combinedly I call it as a term. Here also 3yz is a single term. If you have only one term in this algebraic expression, we call it as a monomial. What is that? Monomial. Next one. If you have two terms, what is that? Binomial. Look here, an algebraic expression with two unlike terms. Why did I call unlike, children? Suppose if I take 5x 2x, 5x plus 2x, if I say two terms with a plus in middle, you may say, what is 5x plus 2x? It will be 7x. Means it become a monomial. So that is the reason there is a word here. Unlike terms, not like. 3x and 2x will be like. So look here, an algebraic expression with two unlike terms. Example, 3a plus 2b, 5x square minus 7y. See here, how many terms we have? Two terms with a plus sign in middle, and here two terms with a minus sign in middle. So this type of algebraic expression we call it as a binomial. And this binomial, I may say it is also a polynomial in two variables. This is also called as a polynomial, I can say. It is a polynomial of having two terms. Polynomial of two terms. If you have two terms separated with a positive or a negative sign, that algebraic expression is also called as a binomial or a polynomial. Next one. More than two. If I use three terms, what is that? 3. Trinomial. So example, ax plus by plus c. Observe here, ax, by plus c. So what is that? Ax is a term, one more term, and c is one more term. So how many terms you have here? 3 terms. 3 terms means it is a trinomial. An algebraic expression containing 3 unlike terms, those are called as the trinomial. Trinomial is also a polynomial. Trinomial is also a polynomial of having 3 terms. More than 3, multinomial. Multinomial, it is an algebraic expression with 2 or more than 2 terms. 2 or more than 2 terms, we call it as a multinomial. Suppose let me take here 5x plus 2a plus 6 plus 7d. So something you have like this. So how many terms you have there? 4 terms you have. So we call it as a multinomial. This multinomial is also a polynomial of having 4 terms. Okay. So next, coming to polynomial, an algebraic expression with 1 or more unlike terms are all called as a polynomial. See here, all these comes under polynomial. So separately, if I say an algebraic expression containing only 1 term, monomial, 2 terms, and they are separated, 2 unlike terms separated with a positive or a negative sign, they are called as a binomial or a polynomial of 2 terms. Okay, so 3 terms, trinomial. More than 2 or 3 terms, multinomial. 1 or more terms, we call it as a polynomial. So once again, what is an algebraic expression? Algebraic expression is a collection of 2 or more terms and are separated with a positive or a negative sign. If you have only 1 term, then we call it as a monomial. If you have 2 unlike terms, we call it as a binomial. 3 terms, polynomial, and more than 2 or 3, we call it as a multinomial. Polynomial, 1 or more unlike terms, we call it as a polynomial. Yes, we need to discuss one more point. Before that point, I want to say you something here. Suppose if I multiply a literal many times. So what happens here? Let me take here a into a. How many times I am multiplying here? 2 times. Right? According to some laws, you know already before. So according to that laws, I can say here a power 1, a power 1. A is multiplied 2 times. You may apply the law 1 plus 1 is equal to a power 2. Or directly you can say a is multiplied 2 times. That is a square you can say. Or you may apply the law a power m into a power n is equal to a power m plus n. So what am I talking here? Power. What is that power? So let's look here. A power n I am saying. What is this a? A is called as a base or exponent and n is called as a power or index. Okay, how do we get here power and base? Suppose if any number, let me take here 5, multiplying 3 times. How do you rewrite this? 5 power 3. Okay, what is the base or exponent value? 5. What is your index or power value? 3. Okay, so now suppose the same thing if I multiply 1 by 3 into 3 into 3. What happens? 1 by, how many times 3 multiplied? 3 times. So I will write here. Okay, one more 3 I will take children. How many times 3 is multiplied now? 4 times. So that will be 1 by 3 power 4. I don't want this in denominator. I need to bring this up. Okay, you should remember one law, that is 1 by x power n is equal to x power minus n. Then the power will be negative. Similarly, if you convert this, if you rewrite this, what happens? 3 power minus 4 is your answer. Observe carefully children, why am I saying this? I'll see you here. If 2 times it is multiplied, a square. 3 times cube. More than 3, 4 times power 4. How many times it is multiplied? That power you need to write here. Okay. Suppose a power n, a is called as a base exponent and n is called as the index or power. This power is always a whole number. Whole number, it cannot be integer. So that is the statement I need to explain here. A power n means a into a into a into so on. How many times it is multiplied? We don't know. Right? Many times if a is multiplied, I write it as a power n. So, if your power is negative, what I can say, it is not a whole number. It is an integer value you are getting in your power. Okay, so look here. For each literal used in a polynomial, its power must always be a whole number. Example, suppose if I take here x cube. What is this? Yes, it is a polynomial. The same thing, if I write 1 by x cube, what happens here children? If I bring this up, x power minus 3, whereas this is not a whole number, therefore, this is not a polynomial. What is the rule here? Polynomial, its power must always contains whole number, not other than whole number if you get, or a negative value if you get in your power, then it is not a polynomial. Okay, now we are going to learn one more important topic, that is degree of a polynomial. What is the degree children? Degree is nothing but the highest power in a given algebraic expression. Suppose I am going to take here x square plus 5x minus 3. This is an algebraic expression of 3 terms. 3 terms means it is a trinomial. One variable I have used in this algebraic expression, that is x. And here x power is 2 and here power is 1. Now I call degree of a equation. What is the degree of a equation? The highest power in a given equation. Here power is 1 and here power is 2. 1 is greater or 2 is greater? 2 is greater, right? Therefore, the degree of the given equation or expression is 2. Similarly, if I ask you 3y power 6 minus 2, if I say, what is the degree of a given algebraic expression? It is a binomial having two terms. Binomial having two terms and its degree means highest power. Its degree is 6. Similarly, if I ask you ax plus b, where b is a constant, okay, and x is a variable and a is a numerical coefficient, you may think. So now, highest degree, what is there? Nothing there means it is 1. Therefore, degree is equal to 1. And this is also called as a linear equation. Any equation, its highest degree is 1, but that is called as a linear equation. Suppose, if your equation, look here, where a, b is a numerical quotient and c is a constant, x is a variable. These are the constant and these are the variables. So what is the highest power? You can see here 1 and here is 2. What is the degree of the given algebraic expression? It is 2. Highest power is called as a degree, right? Therefore, the degree is equal to 2. Then this type of an equation we call it as a linear polynomial and this is called as a quadratic polynomial. And if you have a highest degree 3, then we call that as a cubic polynomial. Okay, once again children, all these are all the polynomials we have discussed, right? Polynomial power can never be integer or a negative value. And polynomial highest power we call it as a degree. And if degree is 1, we call it as a linear polynomial. If the degree of an equation is 2, then we call it as a quadratic polynomial. Suppose if the degree is 3. So look here, what is the degree here? Highest power is 3. Then we call this as a cubic polynomial. Linear polynomial degree 1, quadratic polynomial degree 2, cubic polynomial degree is 3. Okay children, with this we are going to end today's session of our basic. Thank you all.